Hello class and welcome to lesson 2.2b, linear regression, day 2. So today our expectations are going to be as follows. Throughout the warm-up and through our lesson, we're going to calculate the correlation coefficient using technology. So for those who forget, that's the R value. Okay, and we're going to describe any possible misuses of regression, and that'll be carried on a little bit more in the next lesson, in future lesson as well. All right, so say for our warm-up here, we've got an example, and we've got some data. So X, meaning our X-axis, is the days absent from class, versus Y, which is mark as a percentage. So you could pretend the student's doing this as their accommodated project like you're working on. Okay, so if I have a quick graph here, I know that my days absent, or absent classes, is on the X-axis, and on my calculator, sorry, absent classes, let's try that again. Okay, my absent classes are on the X-axis, and on the Y-axis we're doing mark in terms of our percentage. Okay, and we're going to correlate these two. How are these two related? Well, here's a student, Fern, and he entered the data that he got maybe from his primary data, from his survey, or from a secondary source, and he inputted the information into his graphing calculator, and he got the following results. So he got A, B, R squared, and R. I apologize if it seems a little bit blurry. I had to blow it up so you could actually see the numbers. Okay, so I apologize for that. So question A says to write the equation in line of best fit. Well, first of all, today we're dealing with line of best fit. So the equation of the line is y equals mx plus b. However, the graphing calculator doesn't use m, just remember that, it uses a. So it's y equals ax plus b. So all we do is sub in our a and our b values. So we've got y equals negative 2.31x plus 83.6. So what does that really mean, folks? If I look on my graph that I drew here, that means that I start at 83.6%. Wouldn't it be great if you missed no classes and were guaranteed 83.6%? That'd be awesome. And then for every day that you were absent, you dropped 2.3%. Okay, so that's showing a negative downward trend. You guys okay with that? Okay, I shouldn't say that because I probably just gave away an answer or two. All right, so B, okay, says to describe the correlation. So we'll do that first. So the correlation is related to your correlation coefficient. So find your R value. So R in this case, ladies and gentlemen, if you look here, it is negative 0.856. Okay. And what does that tell us if we're talking about the correlation? So the correlation says that it's a strong negative correlation. Okay. Now, when it says the next part, describe the relationship between the two variables, well, what are we going to say? As, whatever the independent is, so as number of days absent increase, what happens to our y-axis? Well, our y is really your mark, so your mark, or you can put your percentage, I'll put a percentage in the bracket, in percentage, will decrease. So that describes the relationship between the two. Okay, next, third was absent for 17 days. What should his mark be? Well, you can use the equation, okay? And what can we sub in there? We're going to sub in x equals 17. We don't have a graph, so guess what? We have to use the equation. We have no other option in this case. He did use technology, however, so he would be able to do it, but we don't have access to the graph to make any interpolation or extrapolation. Okay. So, 17 days absent, you sub in x for 17, plug it in your calculator, folks, and you're going to get roughly or approximately 44%. So, according to this model, not saying it's true or not, but according to this model, if you miss 17 days and you don't catch up or do any work, guess what? 44%. Don't do that. Please don't do that. Okay, D, if you wanted 99% in your class, how many days could you be absent? Okay, well, this is going to be a tricky one, but I'll explain it as we go. So sub y equals 99, because that is the mark you want, into the equation. Okay? So 99 equals negative 2.31x plus 83.6. Okay? Rearrange to get x by itself. So we're going to take the 83, move it over, subtract it from 99. Use your calculator. That's going to give you 15.4 equals negative 2.31x. And how do we get x by itself, folks? Divide both sides by negative 2.31. And here's the crazy part. When you solve it, you got x equaling negative 6.6. You're like, what? That doesn't make sense. And sometimes math, when you do these models, they don't make sense. But if I go back to my graph, we can make a little bit of a sense to it. Okay? So we know that if we miss 0 days, we're only at 83. To get a 99%, folks, I would have to extend or extrapolate my graph up further to get where I'm at a 99%. So if I find 99%, it hits the graph here, which means we're at negative 6.6. Now, that doesn't make sense that you can't be absent negative times. But for reality, I'll put down this. Doesn't really make sense because sometimes math doesn't work in certain ranges. Okay, it's not saying it's not possible to get 99%, but it's pretty darn sure. But I would interpret this, folks, as, hey, not only do I have to be present every day to class, I have to do the equivalent of 6.6 more days of work on my own, studying, doing homework, in order to get that 99. Okay, so you could interpret it that way, but this doesn't really make sense for our answer because it's so out of the scope of the data, because this would be an extrapolation. Okay? All right. Hopefully you enjoyed that. Now we're going to get on to taking a look at tuition over time. Okay, so most of you will be heading off to post-secondary, and this data is again blown up so you can see the data, and I'll just erase that. I'm not sure why I've got that circled, so we will uncircle it. I'll come back to that in a minute. So the data below shows the Canadian tuition, and they did this on a consumer price index. And you can Google what CPI is. I think it's a basket of goods and daily services that we use on a regular basis, and we're comparing it over time. Okay, so instead of doing every data point, folks, I thought it'd be easier just to only enter the red dashes in your graphing calculator. So you're going to do time in L1 and your CPI or your tuition index in L2. Okay, and we're just going to do just the red dashed ones. Okay, all right. So we go to our graphing calculator. I'll just flip it for a second. We go to our stat. We go to enter. You enter in your data points for the dashed lines. Everybody good with that? Then we need to create, I'll go back to the lesson now. And it says create a scatter plot and include the line of best fit. So the first thing we need to do is make sure we've got a good scatter plot. Well, don't forget, when you're going to get your scatter plot, you've got to turn your plots on. Make sure you got scatter plot and that you've got L1 and L2. L1 meaning your years and L2 meaning your values. So make sure you got that set up. And then when you press Y equals, you get a graph. And you can do a zoom 9 to get this data in, and you can see the general trend. Okay, everybody good with that? Awesome. Okay, now that is just the scatter plot, but now it says to include the line of best fit. So to do that, folks, you're going to have to turn your diagnostics on in order to do the regression. Okay, so don't forget to do that. And when you turn your diagnostics on and do your regression, if I put my pen down, that won't slide properly. You're going to notice we've got our line there. Okay? You're going to say, hey, great, Miss R, that's awesome that we've got our line, but it says use linear regression to create the equation. So the equation doesn't necessarily come up on the line. It comes on Y equals. You can press Y equals, and it should be in there. Or when you do your regression, it'll pop up on this screen here. Okay? All right. So let's take a look here at what we've got. Okay, so we've got our line of best fit drawn. Okay, we use the buttons on our calculator sheet to get the linear regression, and we're going to answer the following questions. So B says, tell me the equation of the line. So we're going to use this data right here. Okay, so instead of y equals ax, we're going to go y equals 7.21x. And instead of plus b, we're going to go minus 142,042.83. Okay, so that is the equation of the linear model. Okay, so the line of best fit equation. Okay, so that is this solid straight line right there. Okay. Next it says to give me the correlation coefficient. So the R is your correlation coefficient, and you look here, ladies and gentlemen, and please put a decimal in or a 0 in front of the decimal. Please, 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 thank you. Okay, so that's the R value. And we can describe it now, but the next question is going to ask us to classify it. So we'll do that in the next question. So C says to tell us what it is, and that's going to be the correlation coefficient represents a strong or a very strong positive. If you want to put down very strong, you can, because it's very close to 1, right? So very strong positive correlation. Okay, everybody good with that? All right, and then it says to write a statement describing the relationship. So what's happening over time? So as time increases, so does the tuition fee. Okay. All right, next one says, according to the model, what was the index in 1988? So you use the equation and sub it in. So y equals, so this is D part. So y equals 7.21, 1988. Sub it in. Use your calculator, ladies and gentlemen, and you will get y equals 90.65. Now this is where I want to bring a point to people here. So it said in 1988, and we got an answer of 90.65. If we go up to the original data, just scoot on up here. Okay, this is why I had this circled initially. If we look at that, in 1988, it says, hey, the actual value was 64.7. However, we're using the line of best fit, so I don't want that to deter you. So basically, we're looking at this value instead of that data point. Okay, because we're going on the line as opposed to the actual data point. Okay, so in some cases it's higher, but in other cases it's going to be lower, like at the extensions of the graph here. Okay, all right. Okay, and the last one says, okay, predict the value in years for your last year of university. So you're going to hopefully university the next year, so please sub in whatever year you have here, whatever year you think you're going to graduate in, plug it in there. Okay, so one thing I want to note, folks, before we leave our lesson today is if we look at this data for a second, folks, look at the general trend. Although we did a linear regression and we got 0.96, that's still pretty strong. I want you to acknowledge that maybe a line of best fit may not be the best model for this data. In fact, there's a bit of a curvature to it. So next lesson, folks, we're going to explore non-linear regressions. So we're going to take a look at maybe cubic, quadratic, quartic. There's even exponential, could be. And we're going to explore that and look and see if we can get even a higher R value. All right, so that's something that's coming. If you have this in a graphing calculator, this data, please don't erase it because we're going to use it next day. Awesome. So here's your homework, folks. Page 180, numbers 6 to 8 and 13. Have a great day.